Alright, hi guys, I am here with Rodrigo, and then I'm gonna say your last name and I'll probably get it wrong.
Try.
Fernandez-Gonzalo.
Yeah, very good.
Assistant professor at the Karolinska Institutet, and we're actually standing outside the Karolinska Institutet right now.
Yes, one of the nice buildings.
And we're gonna have a walk and talk.
Absolutely.
Wonderful. And we're gonna be talking about your research, which excites me because it has to do with space.
Yeah, part of it.
Part of it. And we're gonna talk about how you ended up in science. So how did you end up in science?
Well, that goes to my first years at the university when I started my bachelor degree. And actually in my second year I was already thinking about following some physiology research or something.
So you were inspired from the get-go?
Yeah, I don't know. I'm quite stubborn, so that idea went into my mind, and I just went all the way.
Nice.
Until ended up at KI.
Nice.
Plus, I had very good supervisors at the beginning, because I think that's very important.
Yeah.
Not to kill the
spirit.
The spark.
Yeah.
Yeah, exactly.
So, but you always knew that you were going to have a scientific degree.
I would say.
Like, did you dream to be something else when you were a kid?
Football player?
Football player?
I played football since I was 6 and I reached semi-professional level in Spain.
Yeah?
But then when I had to move to study at the university, I decided to just do it for fun.
Yeah.
But I decided to study sports sciences instead.
Yeah.
At the university.
Was that inspired by your sort of your football career, your soccer career?
Yeah, and maybe more because I was doing a lot of sport with my dad.
Yeah.
So almost several times per week together with him. So it was all about doing sports and trying to beat him, which I couldn't until I was 22. So yeah, it's
So sports for you has been sort of a connection with family and fun.
Yes, mostly with my dad.
Nice.
Yeah, and also the friends I've made when I was doing sports, you don't make friends like those.
No.
Anywhere else.
Yeah. So physiology. So
yes.
you started then and got interested in physiology.
Yeah, because it was how I thought you could improve like performance.
Yeah.
And I also wanted to understand how some people perform better than others.
Yeah.
And of course physiology is a good point to start with that question.
And now you study physiology still, sports medicine, but muscle cells.
Yeah, the thing is that in Spain what I did was of course exercise physiology, but studied more the immune system, because we didn't have access to the skeletal muscle.
Yeah.
But when I moved here, of course Sweden is like the mother of the muscle biopsy, right? With Ben Saltin and Bellstrom. So I started to take small pieces of muscle and investigate what's happening at the muscle level, which is very interesting for me.
Yeah. What muscle? Is every muscle the same?
No, not every muscle is the same. And we take most of the biopsies in the vastus lateralis, which is the lateral part of your thigh. Yeah. Because you don't have any nerve or vessel. Yeah. But last year we did a study where we took biopsies from the triceps. Yeah. So I have 6 small marks in my triceps. That was a bit more challenging. But and then you can take in the calf, and you can take muscle biopsies from almost any muscle, but that would be when the subject is undergoing surgery, for example, and you speak with the surgeons to take a small piece of the muscle you are interested in.
And why are muscles interesting?
Well, muscle is the biggest organ we have in our body, skeletal muscle.
Yeah.
So it makes us move, and it's a major source of like energy.
Yeah.
And it's the major metabolic, let's say, controller in the body. So it's very important. For me, it's the most important organ in the body.
But because I was thinking about that, because you've been studying, among other things, how that different types of exercise are affecting muscles.
Yeah, that was actually one of the first projects when I came to KI as a postdoc, was to fine-tune exercise model for astronauts. That's how I started with astronauts. And it has to be as short as possible, but as efficient as possible.
Yeah.
So, yeah.
And what is the challenges if we think about exercise in space or about existing in a zero gravity?
Yeah, I mean, we evolved here on Earth with our gravity force pulling us downwards, right? So once you are in space, your entire body has to readapt in a very short time frame. You don't have millions of years to adapt. So there are alterations that we cannot solve, but what we are trying to do from the scientific environment is to make those alterations as little as possible to keep the astronauts safe and healthy, such that they can perform the tasks they are supposed to do. But you know, so far, a trip to Mars, we can nowadays cope with them like microgravity, but the radiation will be an extra problem.
Yes.
Because the type of space radiation is much higher with these heavy ions like iron and things like that will destroy a lot of cells, basically. We had a very cool project with the cosmonauts. We were looking at whether if you go the second time to space, your body has developed some type of radio protection.
Really?
Yeah. So your body actually develops less damage in the DNA of the immune cells than if you go the first time.
So the first time is the hard one.
Is the hardest one. And we are still, the results are still under investigation to see if we actually develop some radio protection or not. But that would be a cool thing to do.
Yeah.
And an amazing thing from our body.
So what sort of is your inspiration to do this research, whether it's the muscle physiology or it's like the space aspect of it? What is it that sort of makes you go?
Yeah, when you are a kid, you have two things that will take the attention of every kid in the world: dinosaurs and space.
Yeah.
So if when I accepted my postdoc position here with this European Space Agency project, it was like mixing two of my favorite things, like exercise physiology and space.
Yeah.
So I couldn't reject that.
You can't say no to that.
No.
But is that still sort of a driver for you, like that inspiration of that kid inside you?
I think we never lose that inspiration. I mean, everything related to space is intriguing because it's like something we don't really know. What is? I mean, what happens when we go there? What is beyond what we can see?
Yeah.
So it's I think exactly, and that's on one of my interviews. Someone asked me, "Do you think it's worth to put that much money in space exploration?" And I was said, "Well, if you wanna keep human beings as what we have been during history, like we have been curious.
Yeah.
I mean, how the hell someone in the 15th century wanted to travel to somewhere where you didn't know where to go with
outside the realm of the map.
Exactly, with boats that were sinking as a small wind, but still they did it. So now it's the same. Is it worth? Of course.
Of course it is. But do you think curiosity is also what sort of you have with you when you develop your projects? Is that sort of like?
That's I mean, everyone that knew me when I was a kid told me I was very curious, like touching all the buttons and everything. But now the problem is that sometimes you are so stressed by time that you don't have time to develop your curiosity and put that curiosity in your grant application or your project. So I like to think my curiosity is still there. Yeah. But sometimes I would like to have more time to develop that curiosity.
To be curious.
Yeah.
We know that science can be hard. It can be an uphill battle, both in the environment and getting granting for doing the research. What is it that keeps you doing research?
Well, let's go back to my curiosity, I guess.
Yeah.
But I have to say I've been very close to quit science twice.
Yeah.
And there were small details that at the end kept me on the research field.
Yeah.
I have a very supportive family, and I've been lucky at the end.
What impact will research that you are doing have on society, you think? And what's your hope for it?
I will give you an example. For example, quite obvious these days.
Yeah.
You know, with the coronavirus,
Yeah.
in some countries like Italy and Spain, people are not allowed to leave home, so they are super inactive.
Yeah.
So the research we do in microgravity is exploring what happens to the body when you are completely inactive.
Yeah.
So we can actually translate some of the findings that occur only with 2 days in bed to what people will suffer after being confined in their own houses without almost moving. And that's quite scary.
Is that, you think, something that will see an impact on society health-wise?
Yes, absolutely. And in aging population, I mean, we know after only 2 days of being completely inactive, your muscle starts to be anabolic and break down proteins and become smaller in a way.
Yeah, because it's not used.
It's not used.
But
you don't use it, you lose it. That's what.
So in the frail population that may not have a lot of muscle to begin with.
Yeah, then it becomes very dangerous because then they lose. It's like a circle, right?
Yeah.
You don't have a lot of muscle, so you don't move, and you lose muscle, so then you move less, and then you start having a lot of metabolic problems.
Yeah.
And then you can't live by your own, and then it goes like that. Then you maybe fall, and then you don't recover, so you move less.
Some of the research that you did on sort of what happens, what's the possibility of doing activity in space?
Yeah.
Could that be implemented to some extent in a quarantined household?
Yeah, and actually, my former supervisor developed this resistance exercise to build up muscle.
Yeah.
Device that can be used without gravity.
Mm-hmm.
And then we have done a lot of studies in healthy population, in stroke patients, cerebral palsy, multiple sclerosis, aging, and it shows that it's more beneficial than the normal resistance exercise that we do.
Which exercise is
It's
that?
called flywheel, inertia flywheel exercise. And it works very good. It's very tough, but it's very short time that you have to do it. And then you build up muscle like crazy. And to combat sarcopenia, for example, in the elderly, it could be something that could potentially be applied.
Yeah.
But the difficulty is that when we do a project, 8 weeks training, we show these, super nice results. The problem is to have people doing that all the time, non-stopping.
Yeah.
During the rest of their lives, basically. How do you do that?
Of course.
And that's the major challenge we have now with aging population or inactive population. We know we can make them do something for a short period of time that will benefit them a lot.
Yeah.
But then we cannot keep them engaged in that.
No, they come back to sort of a
being
inactive.
I mean, we are all lazy people.
We are. I also have one last question.
Yes.
If I do exercise, like with only half of my body,
yes,
will it affect the other half of the body? If I train just really hard
what type of training? I'm asking.
I don't know, if I like push really hard with one leg.
Yes.
Will that actually affect my, if I only do heavy lifting with my right leg, will my left leg get bigger?
Not bigger, but you will increase the strength in your other leg.
Really?
Because yes, you have the local adaptations at the muscle level, and those will only occur in the leg that you are training. But you have more central adaptations from the central nervous system, and that will also influence how you work with the other leg. So intermuscular coordination, intramuscular coordination, etc. That will make you gain force without training that part of the body.
That's amazing.
Our body is amazing.
I think, is there anything we missed? think so. In that case, I'll thank you for coming out for a walk and talk.
Thanks to you for inspiring all of us, Ulrikke.
And then I will get some links and put them in the notes so people can find you and ask you questions.
Good. Bye-bye.
Bye.